Good day, students. We've been given this beautiful question. We are expected to integrate integral 0 to pi over 2 square root of 1 positive sine x times dx. Now, this looks to be simple, but there is one particular place where it is imperative that the clear stating of the rules is a must. In other words, you have to state why you are doing that. Okay, that is important. Now, this is a very important question. Why? Now, let me just let I to be equal to this integral quantity. Then I wish to write, now 1 is nothing but sine squared x positive cos squared x. We can represent this as this. Vice versa, we can represent this as this. But I'm not going to be utilizing sine squared x plus cos squared x. What I'm going to do is I'm going to represent this as sine squared x over 2 plus cos squared x over 2 is equal to 1. So I'm going to utilize this. Now, why am I utilizing this? Because of the fact that I know that sine 2x is equal to 2 times sine x times cos x. Now, what if I want only sine x? In other words, if 2x is equal to theta, then x is equal to theta over 2. So if I were to substitute 2x is equal to theta, I would get sine theta is equal to 2 times sine theta over 2 times cos theta over 2. Now, why did I do that? I did this because I want to replace sine x with this formula. So this would now imply integral 0 to pi over 2 root of 1. I'm going to write 1 as sine squared x over 2 plus cos squared x over 2 plus I'm going to write sine x as 2 times sine x over 2 times cos x over 2 times dx. Now this entire thing is of the form sine x over 2 plus cos x over 2 raised to the power of 2, right? So I'm exactly going to put this over here. So this is equal to integral 0 to pi over 2 square root of sine x over 2 plus cos x over 2 raised to the power of 2 times dx. Now we got the radical sign, the square root function. When you apply the square root function, most of the times what people will do, they will simply write sine x over 2 positive cos x over 2 and then place dx there. This is wrong. We can't do that. Because when you apply the square root function, you are expected to take in the absolute quantity. If you don't put this, then the question is the solution that the individual is providing is incorrect, right? So this is a very important part in this particular problem. Okay, now next, how to get rid of the square root, or I should say how to get rid of this absolute value. Now this is an absolute value, meaning that you are expected to produce a positive result. Now the question is, to integrate, I need to get rid of this positive. In other words, I need to get rid of this absolute function. So how do I do that? Now I can do that by the fact that the limits, you see that x is element of 0 comma pi over 2. So this would mean x is contained in this interval. So that would mean for given values of x, sine of x over 2 positive cos of x over 2 is always greater than 0. Now because of this all important fact, I can remove the modulus sign. So this is another important step, right? So this is now equal to integral 0 to pi over 2 sine x over 2 positive cos x over 2 times dx. Now I can split this as integral 0 to pi over 2 sine x over 2 times dx positive integral 0 to pi over 2 cos x over 2 times dx. Now let me integrate this. I'm going to state over here, consider integral 0 to pi over 2 sine x over 2 times dx. Now what I'm going to do, I'm going to take x over 2 to be equal to t. So dx over 2 is equal to dt. So dx is equal to 2 times dt. So substitute it there. So this is equal to integral. In place of sine, or I should say x over 2, I got t. In place of dx, I got 2 times dt. Now you don't have to place the limits as yet, right? You just integrate this. So this is equal to 2 times integral of sine t will give you negative cos t. Now what is t? Substitute that, x over 2. So this is equal to negative 2 cos of x over 2. Now you go to the original limits. That's 0 to pi over 2. Now substitute the upper limit. What do you get? When you substitute the upper limit, you get cos pi over 4. Cos pi over 4 is 45. Cos 45 is 1 over root 2. Followed by, substitute this value 0. Cos 0 is 1. Now you can rewrite this. If you rewrite, you get 2 negative 2 times root 2. This is for the first quantity. Okay, for this quantity. So now let me go to this quantity. And I want to use this part of the space. So let me integrate 0 to pi over 2 cos x over 2 times dx. So I know that x over 2, if I were to substitute, I get dx is equal to 2 times dt. So this is equal to integral 2 times. I substitute cos of t, and there is a dt there. The limits, I don't want to place the limits, so let the limits be as it is. So this is equal to, when you integrate, you get 2 times integral of cos t is going to be sine t, but t is x over 2. So this is going to be 2 times of sine x over 2. Now you place the limits 0 to pi over 2. So you substitute the upper limit, you get sine pi over 4. Sine pi over 4 is 1 over root 2. And when you place substitute 0 there, sine 0 is 0. So this is 0. So the value is going to be 2 times root of 2. Now you take this value and this value that you've got here and place them here. So these are all the working. So this is equal to 2 negative 2 over root 2 plus 2 over root 2, right? Negative 2 over root 2, positive 2 over root 2 gets absorbed. So giving you the value 2. So this is a lovely question, and this is the solution to this question. Thank you, everybody. Enjoy your day until we meet again with another question. Like, share, and subscribe.